Good afternoon, everyone. It is an oft-used proverb that you can't have a cake and eat it too. But what if you could? What if there was a way to cut up your cake so that you had twice as much cake afterwards as before you started cutting? This sounds impossible, but it's exactly the conclusion of the Banach-Tarski Theorem, which is more usually stated in terms of spheres than cakes. This says that if we have a solid sphere, there's a way to decompose it into 5 bits, which we can then move around, rotate and so on, and reassemble back into 2 solid spheres, each the same size as the original. The reason this looks impossible is volume. When I cut up the original sphere, the total volume of the pieces should be the same as the volume of the sphere. Now, moving things around doesn't change their volume. I don't get taller if I walk to the shops. So whatever I do to the pieces here, the total volume should remain the same. So the volume at the end should be the same as the volume at the start. But I've just said that it doubles. So what's the catch? Suppose we could make these pieces in the middle so weird that they don't even have a well-defined volume. This, of course, means that they aren't the sort of things you could encounter in real life. They're more like infinitely fine scatterings of dust than shapes like cubes or cones or cylinders. The tool mathematicians use to create these really weird pieces is called the Axiom of Choice, and at first sight it looks quite harmless, rather like a kangaroo who's really waiting for a chance to punch your face off. The axiom says that if we have a load of boxes, potentially infinitely many, each containing a load of objects, again potentially infinitely many for each box, then there's a way to pick exactly one object from each box. If you think of the objects as being white balls, then the axiom says that there's a way to paint exactly one ball from each box red. As I say, not too contentious to look at, but it has some pretty weird consequences. Apart from the Banach-Tarski theorem, there's another theorem, also confusingly known as Tarski's theorem, that says that if we take any infinite set A and its square A times A, which is the set of pairs of objects from A, then these two sets are the same size. If, for instance, we take A to be the set of points on this line, then A times A can be thought of as the set of points on this square. So by Tarski's theorem, the line and the square have the same number of points. But then we can take this one step further and say that the square and the cube have the same number of points as well. So now the line and the cube have the same number of points. But if we blow up this cube big enough, we can get it to fill out the entire universe. So all of a sudden, this line has the same number of points as the entire universe. I hope I've now blown everyone's minds, so we'll be coming back down to Earth next time with the hairy ball theorem. Goodbye.